Alright, let's talk some about inequalities. So in inequalities, we're going to be dealing with four symbols that we don't deal anywhere else in math. We're dealing with this one, which means less than, this one, which means greater than, this one, which means less than or equal to, and this one, which means greater than or equal to. We always read these left to right. That's why I'm reading them that way. So in this case, this would be read x is less than y. Just because that's left to right reading like we're used to in all other subject areas. A little sick, you'll have to forgive me. So, when dealing with these and solving an equation, or, well, solving an inequality, we're going to treat it as if it's a regular equation, except in really one specific case. So let's talk about that real fast. Let's just pretend that we have the inequality 2x plus 5 is greater than 7, okay? This means that whatever ends up over here after we plug in a value for x has to be greater than the number 7. But to solve it and figure out what all values of x work for that, we treat it like we would treat any other equation. So we're going to subtract 5 from both sides. We'll get 2x greater than 2, because that sign just comes straight down. Then we're going to divide by 2 on both sides, and we'll have x is greater than 1. So what that means is, any number that we plug in to this first inequality that we started with, that is greater than 1, should result in a number greater than 7. So let's try it. Now technically it does mean any number at all, so plugging in the value like 1.000001 would work because that is technically larger than 1, but it's much easier to just use integers. So I'm going to use 2 because 2 is greater than 1. So if I plug that in over here, we get 2 times 2 plus 5 greater than 7. Following our order of operations, that gives us that 4 plus 5 is greater than 7, which ends up being 9 is greater than 7. And that is true. So we're good there. Now, if we were to plug in 1, let's look at that real fast. 2 times 1 plus 5 greater than 7. That's 2 plus 5 greater than 7. That's 7 is greater than 7. This does not work because 7 is not larger than itself. It is equal to itself. Now again, I talked about there being a very small amount of cases where things are really different, so let's look at one of those with a very similar example. I'm going to say that I have negative 2x plus 5 is greater than 7, okay? So if we were to look at this, we're still going to solve it almost the exact same way. We're going to subtract 5 from both sides. That gives us negative 2x greater than 2. Then we're going to divide by negative 2, because that's the coefficient of x. But this is where things change. All that's going to happen is we're going to take our inequality sign and we're going to switch it. So right now it reads greater than. We're going to change that to read less than. That's it. We continue as normal. Negative 2's cancel out. We have x. 2 divided by negative 2 is negative 1. So we can check our answer again. This one is a little bit different. It tells us anything that is less than negative 1 will work as a solution for x. So if we plug something like that in, such as negative 2, because negative 2 is in fact less than negative 1, we have negative 2 times negative 2 plus 5 is greater than 7. That gives us 4, because the negatives, two negatives being multiplied create a positive. 4 plus 5 is greater than 7, and then 9 is greater than 7. Now you'll notice that when I plugged it back in, the inequality sign stayed the same as it was originally. It only switches when you actually are solving it and go through that step of multiplying or dividing by a negative number, which is what we did there. So when we plug it back in, it stays the same as it was originally. Now, the only other thing that's odd about inequalities is when we graph them. So I'll start with graphing 2 on a number line. So I should have this in here. Good. And we'll get another one of those up real fast. There we go. Now, on this top one, I'm going to graph x is greater than 2. And on this bottom one, I'm going to graph x is greater than or equal to 2. They're going to look very, very similar with one slight difference. The top one, I'm going to draw my circle there at 2, because that's the number of reference that we're using right there. It's the number that shows up. I'm going to shade in the part to the right, because that's the area that's greater than. This bottom one, I'm going to draw a circle, and I'm going to shade it in, and then I'm going to shade in the area to the right, just like I did before, because that's the area that's greater than 2. The only difference between these two is whether or not the circle itself is shaded in or not. The shaded in circle means that 2 is part of our set of solutions. That is to say that if we plug 2 in for x, it works. The open circle means that 2 does not work and is not a part of our solution set. And this makes sense if we try to plug it in. On the top we would have this, and on the bottom we would have this. Now this top one reads 2 is greater than 2. And that's not true, because 2 is the same number as 2. So there's nothing we can do there. That's simply wrong, because 2 isn't bigger than itself. The bottom one, however, reads 2 is greater than or equal to 2. Now in math, when we have the word or, we just have to satisfy one of the parts of it. So if it's A or B, and B is true, then the whole thing is true. In this case, it's greater than or equal to. 2 is equal to 2, so we have to count the whole thing as being right. Therefore, 2 greater than or equal to 2 is a correct statement. So we get to color in our little circle down there. Where you might see this is in your piecewise functions. Take, for example, the piecewise function where we have, that's an x. We have y equals x if x is greater than 2, and negative x if x is less than or equal to 2. The number that matters here is 2, so I'm only going to graph that one. Now, when we look at this, we see that y is equal to x if x is greater than 2. So starting at the point 2, but not including that point, therefore I leave it as an open circle, our graph is our regular y equals x linear equation. Meanwhile, starting at the point 2 on the x-axis and including that point, so I color it in, our graph is equal to y equals negative x. So this piecewise function looks like this when we graph it, where it's negative x when it's every negative number all the way leading up to positive 2, right there, because it can be equal to 2. And then after 2, but not including it, therefore we have that open circle right there, it becomes the graph y equals x. So we graph that line after that point, and we show that it starts at that point but doesn't include it with that open circle. Now I'll talk more about piecewise functions later on, but hopefully, at least for now, this has made inequalities a little bit better for you.